Hello, this is part 2 of a video series on Sorcar basics, procedural modeling with Blender add-on Sorcar. In this video, I'm going to be covering the for loops and be building another LOD mesh with a collider. I'd like to do the basalt columns here that got up as a reference image. I want the character to be able to jump around on them, so I want a very clean physics mesh to raycast to in-game. This time we'll start from something we've created in Blender and would like to do a procedural modeling with. So I'm going to enable one of the add-ons that comes installed with Blender but not enabled, extra meshes. Enable that. Honeycomb. A nice grid of regular polygons. Okay. So honeycomb is the name of the grid I'm starting with. It doesn't have any faces, at least not in the center. Take a look. Oh. So in Sorcar, we'll start a new graph and import a custom object. Here we'll just select honeycomb, set preview, and see it's created the object and it's hidden honeycomb by default. It's the standard behavior when you add a custom object. Just don't have faces yet, so I'll add them. And we'll take a look at the first, under flow control, there are 3 types of loops. So take a look at the first one for each component. Now this will begin looping through each type of component that you have selected for the object. Each loop has an end that matches it, so bring out both of those. The pink input goes to the end there. And your object will be output here, each individual face, along with its index. And I just want to extrude these in the Z direction. Here we can do it individually. It's pretty much the same as doing it in a loop, but just to show off the loops, send in the object, make a vector, and we'll use a random number. So the float, random float every time. Into the Z value, extrude that, and output the object. There we go. See, it looks like we might need to go in the other direction, and there is more geometry there than I thought originally. So let's start back here and delete some of that geometry that it started with. We'll try by dissolving the degenerate components. Try to extrude again. Try a limited planar dissolve as well. And it looks like there is one face that sits on the bottom that's been extruded, so I will look for that space, or that face specifically. Select by location. This will be right in the very center. There, that face. And I want to delete that. Now everything's been deselected, so reselect everything. There we go. Turn off X-ray, and everything seems to be good. You can add a clamp down here. Maybe just ensure this is up off the ground a little bit. And rather than have this plain grid, let's cut out some of these on the outside. So select by location again. This will be demonstrating taking a selection and then adding more to it. Set the preview. We'll extend this to cover most of the area. And I'll use select random to add to this. There we go. To delete the opposites, we'll use select all again, this time setting to a different mode, invert, and delete these faces. Now when we start the loop, they need to be selected again. It's deselected. So this is a good start. Now I'll use the basic for loop, which is just a loop using a counter. It doesn't consider the number of objects or components in an object. In for loop, I'll bring out the end of it and connect it. See iterations is set. Will be how many times it loops through. Now I want this to step up just one each time, and every time we'll make a other random selection and step those up. To make the random selection different every time, I'll just use the seed as, or the counter as the seed. It'll increase the seed each time. Right now I'm only planning on doing it 3 times, but we could make this more general where maybe the percentage is calculated based on how many iterations you want to run. And we'll extrude. Okay, looks like only that last face in the last loop it was selected, which is definitely showing in the viewport. So all this needs is select all. And here it's likely the selection type, so I'll unhide here, we'll select only faces. And then select random, also select faces. The problem is still the faces I've selected. So we'll use a different method of select by normal. It's a useful one. And here, just want the faces that are pointing straight up. And it looks better. Now here is where the percentage is coming in, where it might be more useful to have a smarter equation set up. So add in a number. This will be for how many iterations I want to do. I'll use the math nodes. First I'll divide 100 by the number of iterations that I want to do. And I'll want to maybe increase that every time I loop through. So we'll need some base value to start from. There are variables. Select the node tree that you're using. Name this cumulative just percent. Not sure whether to take the out or the value. Maybe it will both be the same. So we'll want to add this. Maybe set its value. We'll add this every time we loop through. the value of the current percent to the fractional amount. We need to get the variable. Which we'll do right here. Values being added. To that. And this will be the percent. Then we'll set this before the loop. We should probably set the variable every time we change it. Take another look at the select by normal node. It's not quite grabbing everything it should be. It's probably just because these tolerances are too tight. Perhaps the normals were wrong. Or everything just needs to be selected again. So I've added some small tolerances here. It's selecting everything. Take a look at the output. Yeah, it's what I'd like for the physics mesh, for the overall shape. So we'll clean up some of the geometry that was added through the extrudes. Select all. We'll do a limited planar dissolve, which will get rid of the faces that are lying on the same plane. To unhide node. There we go. And I think this is good for one of the LODs and the physics mesh. So now I'll work to create the FBX structure and parent them and create those two instances. And we'll take a look at making the main mesh the LOD0. So to start, I'll name this node graph. So it'll just be the basic one. I'm going to use this object for both the physics mesh and the LOD1, and I want it under an empty. So I'll create the empty now. Parent it. So I'll name this. This can be the physics mesh. Let's call basalt phys. There we are. We'll add a material. Which we'll need to create a material. And we'll parent this. I'll set the name of the parent. Result group, just like before. You see everything's changing automatically. Now here I will just duplicate it in this graph for the LOD. LOD1. Okay, got two of the things I need loaded up. Now here's what I'm talking about, a better workflow. I have another graph, or I can click here to create another graph, and I'll name this LOD0. We're going to import a custom object like we did before. Nope, custom object. Whenever we make changes to this, we'll have to reset this object in the second graph, but otherwise it's pretty clean. Because it hides the other mesh that you're working with. So for this object, we're going to just select by normal again. Grab the tops and we'll put a bevel on them. Let's use the same settings as before. Okay, a lot of hidden options here. It's also just a straight bevel. Maybe we'll try that. All right. And I'll rename this object. So LOD0. And we should have something ready to go. So I can move this to a different collection and hide these. Select everything. Just export as we did before. like to go over the very last for loop. So we'll create a new, save this. We'll create a new file. I won't create an LOD for this or anything. This will just be for demonstration. So in a new graph, I'm going to create a grid. I'll also show you how to use noise here. This is fine for the settings. See if there are any faces. Okay, and I'll delete the faces. Just want the sort of grid of vertices for this. I'll go back and select all the vertices. Okay. So now we'll use the last for loop. Begin for each. This takes an array of any type. Looks up much like the other one, but you see the array takes the place of the account of the basic loop. So this grid will be the input object. We're also going to use a node that's in utilities menu. Some good ones here: object info, scene info, component info. Here we'll use object info. We'll connect that up. Nothing shows initially, but when it's run, it'll be populated with all of these numbers appropriately. So we're going to go total vertices, and that will be the array. It's going to loop over that number. You don't have to supply the count. I'll add in the basic noise from the noise menu to see what it takes. You can select the noise type, but otherwise you need to supply a position. So for position, we'll get that from the utilities menu, component info. Select the vertex component's location and supply that to the position. Now the value output will be different for every vertex. With this, we're going to do a local transform. And add that to the Z in edit mode. And there's one last thing, we're going to have to supply the object, but we need to select the specific vertex. So we're going to use the select by index, which will be useful when working with these info nodes. So the object out and the element out. Index isn't actually used. That is the count, not aligned with the index of the vertices. This will be supplied to object. That finally is the output node. There we go. Now, you see two meshes on there. I've made a change and sort of broken how it's generating procedurally. I'm surprised this hasn't come out before this, but it's very simple to fix. You just delete everything, which seems bad. You can either reset your previews, or you could go to the end node here if it was already selected and hit execute node there, and that regenerates everything. So that's how you use noise and how you use the for loops. Hope you enjoyed the video, and I'll see you next time. Thank you.